All right, another thing I want to go over from chapter 8, just again, one topic. I'm not going to do intermediate forms, just I want to cover L'Hopital's rule. Now, L'Hopital's rule comes up in this case in specific situations. Okay? If we wanted to find the limit of a function at a certain point, but the problem is that gives us a specific solution once we plug in the limit. For example, if I find the limit of this function, what I normally would do is I would plug in 1, right? The natural log of 1 over 1 minus 1. That's not 1. Right? And that gives us 0 over 0, because natural log of 0 is 1. Natural log of 1 is 0, and 1 minus 1 is 0. So this gives us a situation where I have 0 on the numerator and the denominator. Right? In this situation, if I have this, what I can do is what's called L'Hopital's rule. Okay, so let's look at what L'Hopital's rule is. Okay, so we have the limit as x goes to a value of fx of g of x, where both f of a and g of a approach 0 as x goes to a. So f of x and g of x both approach 0. So top and bottom become 0. Okay, intermediate form type 0 over 0. Okay. Now, what that's going to do, what I'm going to do, okay, it also works if it has infinity over infinity. Okay. So you get infinity over infinity or 0 over 0, you can use L'Hopital's rule, which is this right here. Okay, that the limit of f of x over g of x and the limit is equal to the limit of f prime of x over g prime of x, if the limit on the right side exists or is infinite or negative. Okay. So as long as you have either 0 over 0 or infinity over infinity, then you can use this rule. So going back to finding the limit as x approaches 1, what I can do is the derivative of this function. So we get, that gives us the limit as x approaches 1 of, again, we just went over the derivative of natural log of x. Derivative of natural log of x is 1 over x. Okay, so 1 over x. And the derivative of this is 1. So if I plug in 1, I get 1. And there we go. I have a solution for it now. That's L'Hopital's rule. That's how great this thing is. Let's do another one of these. All right, so let's look at, yeah, this one had a solution. This one has a solution. Same thing as x goes to infinity. If we do the same thing, we said it was the limit as x goes to infinity of 1 over x over 1, which would just be 1 over x. Okay. Limit as x goes to infinity, 0. Remember, the x is in the denominator. As that gets bigger, it ultimately becomes 0. Done. See how great this rule is? Makes things so much easier. Derivative, again, derivatives are nice. Okay, now that you know how to do them, they're nice. Okay, so let's look at another one of these. I bet we have one. So we already did that one. All right, I guess we don't have any more. Okay. That's L'Hopital's rule. So I'm going to give you a couple questions where I'm going to ask you to find specific limits, and it's going to say use L'Hopital's rule. So basically, just take the derivative of the numerator and denominator and then plug in the value. Okay? It's not going to be the tricky use the limit definition of a derivative stuff. It's going to be really straightforward. So expect a worksheet on 7.4 and 7.8. So make sure you watch the videos for 7.4. Again, why am I saying this now? It's the end of the video for 7.8. I'm tired. Okay. So again, 2 short videos, 1 homework assignment on these 2. I'll post this together, and I'll post a worksheet with this. Okay. Then after this, we're gonna get started with chapter 6, which consists of 5 lessons, and that'll be it for the semester for us. Okay. I don't know what is going to happen. I don't know if we're coming back at the end of this month. I just don't know. Okay. Okay. Stay safe. Wash your hands. Do your homework. Okay. Fun.